So I'm going to start with a little example data set here. This data set comes with the ggplot2 package, so you can always just load it up after you install the packages, after you install the package. And so this is the MPG data set. It looks at miles per gallon for a variety of different types of cars. And you can see that in this data set from the STIR that I did that there's 234 observations, so there's 234 different types of cars, and there are 11 variables that are measured. In particular, I'm going to be looking at the displacement variable, which is an indicator of how large the engine is. So this is the DISPL variable. We're looking at the number of cylinders and we're going to look at the highway mileage, so the HWY variable, and then we're going to look at the DRV variable, which is what kind of drive it is. Is it a four-wheel drive, a front-wheel drive, or rear-wheel drive? So notice how the factors here are labeled appropriately. So, for example, the manufacturer variable is labeled by the manufacturer of the car, Audi, Chevrolet, etc. And then the DRV variable, which indicates the type, the drive, is indicated with the 4 for four-wheel drive, F for front wheel, and R for rear wheel. So a very simple plot you can make, I call this the hello world for ggplot, is to call the qplot function. On the x-axis I had this displacement variable, which is the kind of engine size variable. And then on the y-axis I got the highway mileage. And you can see that I specify the data frame with the data argument. So I say data equals MPG, so the data come from this MPG data frame. And so that's very simple. You can see that the plot that it makes looks very different from the traditional base plot. You see that there's kind of a gray background and there's white grid lines behind it. The points are closed solid circles rather than the kind of the typical open circles from the base plotting system. And then there are labels on the x and the y-axis. One of the things we can do is modify some of the aesthetics, so we can highlight different subgroups of the data. So one of the subgroups can be determined by, so there's lots of different cars here. Some of them are front-wheel drive, some of them are rear-wheel drive, and some of them are four-wheel drive. So we can separate those observations out by looking at the DRV, the drive variable. And so I've specified the x and y coordinates just like before. I specified the data frame just like before. And then another argument I have is the color variable. And I'm going to say that the color is mapped to this drive variable, DRV. And all that says is that the different levels of the drive variable will be each assigned a different color. And notice I don't specify what those colors are. They're specified automatically. So you can see on this new plot here that the front-wheel drive cars are in green, the rear-wheel drive cars are in blue, and the four-wheel drive cars are in red. And so you can see that the front-wheel drives tend to have the highest mileage, the four-wheel drive tends to have the lowest mileage, and the rear-wheel drive is something in the middle. And notice that the legend was placed on the plot automatically, and the color coding the different levels of the factor variable. I didn't have to do anything special, and so it's very nicely kind of organized and thought out, and you don't have to do anything. Everything's done automatically. Another thing that you sometimes want to add is a statistic. So a statistic is just some summary of the data. And so the summary that we've chosen to add here is a kind of smoother, or the more technical name is called low-S. And it smooths the data, so you can see the kind of overall trend in the data set. And you can see that I do this by adding the geom argument. And the geoms that I want to put on this plot there's two types. One is I want to add the points themselves, so I can see the data. And then I want to add a smooth geom. And the smooth is this blue line that goes across, and the 95% confidence intervals for that line are indicated by the gray kind of zone. You can make a histogram with the qplot function by only specifying a single variable. So here I only specify the highway variable, and it shows me the highway mileage for all the cars in the data set. But then again, I like to kind of separate out which cars are four-wheel drive, which cars are front-wheel drive, etc. So I specify, instead of the color argument, I specify the fill argument, which says that the different elements of the histogram are going to be filled with different colors based on what drive they are. So here you can see a similar picture that you saw before, which is that the four-wheel drive vehicles tend to have the lowest mileage, and the front-wheel drive tend to have the highest mileage. Another feature of ggplot is called facets, and the facets are like panels in lattice. The idea is that you can create separate plots, which indicate, again, subsets of your data indicated by a factor variable, and you can make a panel of plots to look at separate subsets together. So one option would be to say to color code the subsets according to different colors, like we did before. But if you have a lot of data points, that can be tricky to look at, and then all the colors might overlap, and it may be difficult to see the separate groups. So an easier way to do that is to say split out the three groups into separate panels and make three separate plots. So that's what we've done here. On the left side here, I've got three different scatter plots of the displacement versus the highway mileage, and then I've split it out by the different drives, so four-wheel drive, front and rear. And so you can see the relationship for these three subgroups, and it's just a different way to look at the data rather than, say, color coding the three groups. And I specify this with the facets variable. So I can, and the facets variable takes a format that's basically, there's a variable on the left-hand side and a variable on the right-hand side, and they're separated by a tilde. And so the variable on the right-hand side determines the columns of the panels, and the variable on the left-hand side indicates the rows of this kind of matrix here. Now notice that in the left plot, which is outlined by the red box, there's only one row. And so there's no variable that indicates how many rows there should be in this plot. And so that's why in the facets argument I have a dot on the left-hand side. On the right-hand side, I've got the DRV variable, which indicates that that should indicate how many columns. And now, because there are three levels to this DRV variable, there are going to be three columns. And so since there's only one row, there's going to be three plots all in a row like that. On the right-hand side in this plot that's outlined with the blue box, I've got three histograms. And notice that I put the DRV variable on the left-hand side of the facets argument now, so that indicates I want three separate rows. But because there's nothing on the right-hand side of the tilde, I have no column. So I just have the one column, no extra columns. So I just have the one column for the three plots. And now I've got the three histograms. You can see you can look at the highway mileage divided up by the three groups. So that's a quick example using the qplot function, using some of the data in the ggplot package. I want to go through a slightly more involved example using a data set that comes from Johns Hopkins. So this comes from the mouse allergen and asthma cohort study, which is a study conducted here at Johns Hopkins of Baltimore children aged 5 to 17. These children all had persistent asthma with an exacerbation in the past year. And the overall goal of the study was to study the indoor environment, so the home environment of these children, and its relationship with asthma morbidity. So if you're interested in kind of seeing what a little bit of this was about, we have a recent publication, and I give the link here. So here's a little bit of the max data. You can see that there are 750 observations, and I've just put 5 variables here for the sake of demonstration. One is the ID variable. The second one is the ENO. So exhaled nitric oxide is a measurement that we take that roughly corresponds to a level of pulmonary inflammation. So a large value of ENO indicates some pulmonary inflammation. The second variable here that I want to highlight is fine particulate matter. So this is dust that is less than 2.5 microns in diameter. So it's very fine dust. And the last variable I want to point out here is these mouse positive variables. So this is a skin test that the children do, which it tells us whether they're allergic to mouse allergen or not. So here's a basic histogram of exhaled nitric oxide. So this is the log of exhaled nitric oxide, and you can see it has kind of an interesting shape. It looks like there's 2 peaks, or maybe even 3 peaks there as you go across the histogram. At the bottom of the plot here, I've got the code that makes this histogram, in case you're wondering how you make it. And so I use the qplot function to make the histogram. I've made another histogram, but I've color-coded the different groups, and the groups are determined by this mouse positive variable. So I've separated out the people who are are sensitized to mouse allergen and the people who are not sensitized. So the people you can think of the children that are sensitized to mouse allergen are more allergic, and they may be more sensitive. They have more sensitive to a variety of environmental triggers. And so you can see that roughly from the data, the blue bars are slightly higher, and the red bars tend to be slightly lower. So that suggests that the children that are mouse positive have slightly higher pulmonary inflammation on average. Another way to visualize this data is to kind of do a density smooth. So you can see that on the left-hand side, I add the geome density and to this log E&O variable. You can see that there are at least 2 peaks from the density smooth, and if you separate those peaks out on the right-hand side, notice I say color equals MoPos. So that's I split out the colors by whether they're positive to mouse allergen or not. And you can see that the 2 peaks roughly correspond to whether they're allergic to mouse allergen or not. And so this is a nice way to visualize this kind of one-dimensional data. Now, if you want to look at some scatter plots, I want to see whether exhaled nitric oxide is related to the level of fine particulate matter in the home. And so I'm going to look at PM2.5 and ENO. On the very leftmost side here, you can see I just make a simple scatter plot of log ENO and then log PM2.5, and it's a little difficult to see exactly what the relationship might be, but we'll kind of go piece by piece here. In the middle plot here, I made the same scatter plot, but I've separated the 2 groups, so the mouse positive and the mouse and the non-allergic and the allergic children are separated by different shapes. So here I specify the shape argument, and I assign the shape to be this mouse positive variable. Now it's not really easy to see the 2 groups here. So there's one group that's triangles and another group that's circles, and because of the overlapping of the points, it's a little hard to see. So in the right-hand side here, instead of separating the 2 groups by shape, I separated them by color, and it's a little bit easier to see the 2 different groups in this plot now. One of the things you can do is to smooth the relationship between log PM2.5 and log ENO, and I want to look at how this relationship is different in the 2 groups. So I set the geome to be a point and a smooth, and rather than use low S, I'm just going to say I just want to use a standard linear regression model. So I say method equals LM. And that way I can look at the linear relationship between PM2.5 and ENO by whether they're allergic to mouse or not. And you can see that, roughly speaking, in the non-allergic children, so these amongst the red dots here, there's a little bit of a negative relationship, but it's not particularly strong if you factor in the kind of the confidence intervals there. And then within the allergic children, there appears to be an increasing relationship between PM2.5 and ENO. So another way to look at the same data is to split it out with facets. So rather than overlapping the 2 groups and then color coding them separately, I can just split them out into 2 plots using the facets variable. So the facets argument. So here I specify the facets argument, and I say I want 2 columns designated by the mouse positive variable. So no and yes. So there's going to be 2 columns, and you can see, and then I smooth the relationship within each panel, and you can see that again it's the same story. Amongst the mouse negative children, there's a small decreasing relationship, and amongst the mouse positive children, there's a slight increasing relationship. So the qplot function is a simple function that you can use to make very quick plots, and it's analogous to the plot function. So you specify x, y, you specify your data, and then there's a variety of options that you can choose. There are a lot of nice built-in features. So if you want to color code subsets of the data, it's very easy to do. If you want to split out different panels, that's also very easy to do with the facets. You can choose different plotting symbols with the shape argument, and so it has a lot of nice things that you can do very quickly, but that are still very powerful. The syntax for the function is somewhere in between kind of the base plotting and the lattice package. I think the graphics that are produced are very nice if you like the type of design. But if you don't, there are features that you don't like, or you don't like the design of this particular function. It's a little bit tricky to kind of modify the qplot function to suit your needs. If you want to do kind of a lower level customization of different aspects of the plot, you really have to go into the kind of the guts of the ggplot function, and that's something that I'll talk about in the next lecture.